Express rth moment about mean in terms of the various movements about the arbitrary point A. Again, we have been talking about movements around origin, movements about mean, and movements about some arbitrary point also. And we've talked about two properties of movements as well in the earlier class. So this is what we talked about. Now, let us just try to derive this. So I'll do it in two ways. Achha, one thing is when I say mu1, that is the first movement around mean. So that I can write as summation of f x minus x bar upon n. So that is summation of fx upon n, x bar being constant will come out of the summation sign, summation f upon n. So this is nothing but x bar minus x bar, summation of f upon n, that is equal to 1, right? So basically what you have, this thing is 0. This thing is 0, right? Mu1 dash, that is the first movement around an arbitrary point, let's say. So it is x minus a upon n. So it is summation of fx upon n minus a being constant will come out of the summation sign upon n. So summation of fx upon n, this is nothing but x bar minus a, and here you can write summation of f upon n is just 1. So basically mu1 dash is this guy, right? Okay. So when you write mu2, that is the second movement around mean. Like this, right? What I can do is I can write this as x minus a. I can add and subtract a here. So I've taken just, so what is it that I have done? I have done it like this. That is basically summation of f x minus a. You can take minus common, x bar minus a upon n, iska square, right? So you have what? Summation of x minus a ka whole square upon n, right? But if this is a constant, x bar is constant, a is a constant, this will come out of the summation sign. F upon n minus 2. X bar minus a is a constant. Summation of f into this guy. Summation of f upon this guy, right? Okay, so how do we write this? What is going to be your beta mu1 dash is what? X bar minus a, right? That is what mu1 dash is. That is what mu1 dash is. This is what? Summation of f x minus a ka whole square upon n. So this is the second movement around an arbitrary point, right? This is your x bar minus a is your mu1 dash. So x bar minus a ka square is mu1 dash square minus 2. X bar minus a is mu1 dash, right? Summation of f into x minus a upon n. Summation of f into x minus a upon n is also nothing but equal to mu1 dash. So this is what? Mu2 dash mine plus mu1 dash square minus 2 mu1 dash square. So this is nothing but mu1 dash square. That is nothing but mu2. Hello? That is nothing but mu2. Okay. Now, we could have done this in a little easier way than this, I guess. I mean, we can probably look at what do you call binomial theorem in order to derive this. So I can use binomial theorem basically to derive this. Well, it is a plus b to the power n. I mean, if you want to write that. So how do you write this? Summation of k starting from 0 to n, nck a to the power n minus k into b to the power k. You write it like this. This is what binomial theorem is. This is what you've done this in class 11th also. Just as an example's sake, I'm writing. Let's say a plus b to the power 4. Right? So you have summation of k starting from 0 to 4. 4c k, not 0. A to the power 4 minus k, b to the power k. You will be writing it like this. So when I open this up, I'll be getting what? 4c0 a to the power 4 minus 0 into b to the power 0. I'm just trying to expand a plus b to the power 4, right? Plus 4c1 a to the power 4 minus 1, that is 3, b to the power 1. Plus 4c2 a to the power 4 minus 2, that is 2, b to the power 2. 4c3 a to the power 4 minus 3, that is 1, b to the power 3. And 4c4 a to the power 4 minus 4, that is 0, and b to the power 4. b to the power 4. I'm sure you know that when you just, okay, so how do you just calculate this? This is 4 factorial upon 0 factorial into 4 minus 0 factorial, that is 4 factorial. A to the power 4, b to the power 0 is just 1. 4c1 is 4 factorial upon 1 factorial into 4 minus 1 factorial, which is 3 factorial. A cube b. 4c2 is 4 factorial, 4 minus 2 factorial into 2 factorial, a square b square. 4 factorial, 4 minus 3 factorial is 1 factorial into 3 factorial, e to the power 1 b cube. 4 factorial upon 4 minus 4 factorial is 0 factorial into 4 factorial, e to the power 0, b to the power 4. We can write it like this. And when you will just open this up, I'm sure you guys can. So this is going to come out to be a to the power 4, 4 a cube b plus 6 a square b square plus 4 ab cube plus b to the power 4. This is what we're going to do. This is what we're going to get, right? So just as an example's sake, if you just calculate this guy, so this is nothing but 4 factorial upon, so 4 factorial is 4 into 3 into 2 into 1. This is 2 factorial, 2 into 1 into 2 factorial into 1, 4 into 3 into 2 into 1. So this thing get cancelled out, right? So you have what, just 2 into 3, which is 6. I don't know why I'm doing this, but I need to just write this, right? So the point which I want to make is just as a recap for a binomial theorem. So it is cumbersome to just expand these formulas. So why don't we just use binomial theorem? So even in our case, so if I write the movement around mean like this, mu r, that is 1 upon n summation of f, right? Phi your xi minus x bar to the power r, summation of this guy xi minus x bar to the power r. So I can write this as 1 upon n summation of fi. And again, I can add and subtract a. So I'll be getting xi minus a plus a minus x bar. I can write it like this. This is exactly like what you did earlier. This is exactly like what you did earlier. But since you were just squaring this, it was easy. But right now you're trying to do it for a more general term. So I'll be using what binomial theorem here? I'll be using what binomial theorem here. So when you will open this up, so this is your, just say in this example. So this is what your capital A is, this is what your capital B is, right? This is what your capital B is. Okay. So you have what? RC0 into x minus a to the power r into a minus x bar to the power 0. Right? This is exactly same as this. They say 4c0 a to the power 4 minus 0 b to the power 0. That's what you have been doing out here. Just expanding it using binomial theorem. Plus RC1 x minus a to the power r minus 1 a minus x bar to the power 1 plus RC2 x minus a to the power r minus 2 a minus x bar to the power 2 and so on. RCR this is xi minus a to the power 0 a minus x bar like this. So can I write it in some way? Okay, now this is just 1. This is just RC0 is just 1. So it is what? 1 upon n summation xi, summation fi into xi minus a to the power r into a minus x bar to the power 0. This is what your 1 is. Plus, right? Plus, or should I take one more step in order to write all this? Okay, chalo, take it. It is 1 upon n your RC2 summation of fi xi minus, not RC2, RC1. Summation of fi xi minus a to the power r minus 1 e minus x bar plus 1 upon n RC2 summation of fi xi minus a to the power r minus 2 a minus x bar, and so on. 1 upon n, this is just going to be 1, right? Summation of fi. This is also going to be 1, right? Oh, this is very good. So you can just write this as a minus x bar into, because this summation of, I can write this is 1 beta. Xi minus a to the power 0 is also 1 into 1 upon n summation of fi. This is also going to be 1, right? Okay. Now just think about it. This, what is this? This is just your mu r dash. No, this is just your mu r dash. This is just the formula for mu r dash plus RC1. What is this formula then? Summation of fi into this guy, your xi minus a to the power r minus 1 upon n. That is mu dash r minus 1 into a minus x bar plus RC2 mu dash r minus 2, right? A minus x bar का स्क्वायर, राइट? अच्छा, ये भी शायद यहाँ पे ये r होगा. This is going to be r, and so on to this thing, and so on to this thing. Are you with me? And so on to this thing. Okay. This is what your mu r is. This is little involved, but it's going to be useful to you because you should know from where these formulas are coming. But a minus x bar, it could be written as minus of x bar minus a, right? So minus of x bar minus a, I can write as minus of 1 upon n summation of fi xi minus a, that is minus mu 1 dash, minus of mu 1 dash, right? Minus of mu 1 dash. I can write like this. So wherever this is there, your a minus x bar, I can write minus of mu 1 dash. So mu r is mu r dash minus RC1 mu dash r minus 1 into minus mu 1 dash plus RC2 mu dash r minus 2 into minus mu 1 dash square, and so on. So this thing beta, your a minus x bar, it is going to be what? Your, this is to the power r, na? So it could be written as minus 1 to the power r mu 1 dash r, mu 1 dash r. Achha, now you put r equals to 2. So you will have a term only till here, this thing, and this thing. So mu2 is equal to mu2 dash minus 2c1 mu dash 2 minus 1 into minus mu1 dash plus 2c2 mu dash 2 minus 2 into minus mu1 dash ka square, right? So what will this be? Mu2 dash minus 2c1 is 2, right? This thing has become what? This is just 1. And with minus mu1 dash, it become plus mu1 dash ka square. 2c2 is 1, right? So this thing is mu0 is what? Just 1. Minus mu1 dash ka whole square, right? So you have what? Your, this was plus or minus? Yeah, minus 2c1 minus mu1 dash. I think I did a mistake here. Yeah, the mistake was that if you're putting a minus x bar to be written as minus mu1 dash here, then you can have one minus. Now both minus can't be there, right? Okay. So this thing is going to be, right? So I'll just write it again. I'll just write it again. So it is mu2 dash minus 2 mu1 dash square plus 2c2 is 1. This is mu to the power, this mu0 is 1 minus, but this thing is going to become plus. So minus mu1 dash ka square is plus mu1 dash ka square, right? Plus mu1 dash ka square. This is this thing. So this thing is going to come out to be mu2 dash minus mu1 dash ka square. This is what this is. Now, only for this formula, I think binomial theorem would look more cumbersome. But when you go into the higher orders, for example, you try to find out for mu3, then doing it by the formula method is going to be very cumbersome. This is what I feel, right? So you've derived the general formula. You can now put r equals to 3. Right? In this expression, you can put r equals to 3. And you guys will be getting this. So you will be getting mu3 as mu3 dash minus 3 mu2 dash mu1 dash plus 2 mu1 dash cube. Similarly, you can also put r equals to 4. Right? And you'll be getting mu4 as mu4 dash minus 4 mu3 dash mu1 dash plus 6 mu2 dash mu1 dash square minus 3 mu1 dash to the power 4. You will have this, right? So, and you should remember these formulas because there can be the question that you want to change, you want to express these central movements in terms of movements around a certain point, right? So we'll do the questions based on this in the other class. Thank you, Beta.